In this video, we're going to talk about how to find a polynomial function when the roots are given. So here's what you're going to see in your problems. You're going to be given directions that say, write a polynomial function with a specified degree. In this case, it's degree 4, with these given roots and an added constraint that it is going to pass through the point 118. So we're going to be doing this today. I've got two problems for us to take a look at. So here we go. We're going to be finding a polynomial degree 4 with these given roots. So the first thing we're going to do is use these given roots to come up with some factors. So what factor would yield the root -2? It would be the factor x plus 2. Remember, the roots are the same things as solutions or x-intercepts. So roots, solutions, x-intercepts, zeros. They come from specific factors. X plus 2 would yield the root -2. So what factor would yield -1/2? That would be 2x plus 1 would yield the root -1/2. Think about it. If we set 2x plus 1 equal to 0, we get -1/2. Now the tricky one right over here is the I. And the way that I like to go backwards and find the factor is, let's first set I equal to x, so x equals I, and then we want to undo the imaginary number I. To undo the imaginary number I, we need an inverse operation, which would be to square both sides. So x squared equals I squared, and of course, by definition, if I is the square root of -1, then I squared is -1. And we can go one step further here, move that -1 over, and we get the factor x squared plus 1. So that's my third remaining factor. So 1, 2, 3 factors producing 1, 2, 3, 4 roots. That's going to give us a degree 4 polynomial. So let's get this set up in order to find the function. So x plus 2 times 2x plus 1 times x squared plus 1. We're going to start by multiplying these together. So x plus 2 times 2x plus 1, x times 2x is 2x squared. X times 1 is plus 1x, and then 2 times x is 4x, so add those together, we get 5x, and 2 times 1 is 2. Whoop, put 2 twice. We're going to multiply this trinomial times this quadratic binomial, and this is going to take us to our function. So 2x squared times x squared is 2x to the 4th. 2x squared times 1 plus 2x squared. Next, we're going to multiply the 5x through. 5x times x squared plus 5x cubed. 5x times 1 plus 5x. Lastly, 2 times x squared. And I'm just going to stack up these like terms right here so I can add them. And then 2 times 1 is a plus 2. So only one set of like terms when we add these like terms, combine like terms here. 2x to the 4th plus 4x squared plus 5x cubed plus 5x plus 2. So right now, this is our function. Now we have used the first given, and we have used the second given condition, which were the roots. Now we need to utilize this last constraint right over here. So does this particular function pass through the point 118? And if it doesn't, then we need to find some coefficient that we're going to multiply through by. So let me get a fresh sheet of paper. So here we go. So we're testing f of 1 equals 18. So to do that, it's going to look like this. So 18 equals a times f of 1. If this is our function, we are going to let x be 1. So I'm plugging in a 1 here, 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 and here. So that's going to be 2 times 1, which is 2, 4 times 1, which is 4, 5 times 1, which is 5, 5 times 1 again, and then plus 2. So this is going to allow us to find out if we need to change our leading coefficient. 2 plus 4 is 6, plus 10 is 16, plus 2 is 18. So 18 equals A times 18, A is 1. So what that means is we don't need to change this. If A were something other than 1, then we would simply multiply through by it. However, A is 1, so this is our answer. We can also check it on your graphing calculator. You can check this function. Let's graph it. So 2x, whoop, need to clear there, clear, and clear. So let's plot this function, 2x raised to the 4th plus 4x squared plus 5x to the 3rd. It's not in descending order, but that's all right. Plus 5x plus 2, and try that again since I didn't do it right. Now go down. All right, now I've got it in right. Look at that graph. Now, how do we check this? We can look at this function and be certain that it passes through the point 118. We can check that if we use the table function right over here. Second graph, and the second function of the graphing key takes us to this table of values, which you can see right there. If we have 118 included in our table, then we got a thumbs up that this actual function passes through the given point 118. So we're good. So that's the first one. Let's take a look at the second one. I'll move a little bit faster here. So look at what's given. We want a third degree polynomial. We've got zeros at 6 and 5, negative 5 plus 2i. So, and then of course we've got this constraint, f of 2 equals negative 636. So let's start with 6. What factor would give us positive 6? X minus 6. And this second one is a little trickier. I'm going to do it just like the last one. Set it equal to x. X equals negative 5 plus 2i. So we're trying to use inverse operations in order to find what quadratic factor would yield this as a root. So to do that, if x equals negative 5 plus 2i, start by moving the 5 over. X plus 5 equals 2i. Next thing, we want to get rid of that imaginary number, so we are going to square both sides. So that's going to be x squared plus 10x plus 25 equals 2 squared, which is 4. I squared is I squared. And of course, I squared we know is negative 1, so 4i squared is just going to become negative 4. So we want to bring that negative 4 over, and it's going to become positive. So our quadratic factor is going to be x squared plus 10x plus 29 equals 0. So here are our two factors. X minus 6 times x squared plus 10x plus 29. So these are the two factors that we need to multiply together in order to come up with a polynomial of degree 3. So let's distribute. X times x squared is x cubed. X times 10x plus 10x squared. X times 29 plus 29x. Now take the negative 6 through. Negative 6 times x squared, negative 6x squared. Negative 6 times 10x, negative 60x. Negative 6 times 29. So if 6 times 30 is 180, 6 times 29 is 174, negative 174. Checking my work, yes. Now let's add those two together and get our polynomial. X cubed plus 4x squared minus 31x minus 174 equals f of x. So we need to determine if our current function passes through that point. So we're going to set f of x equal to negative 636. And we're going to put an a up front to see if we need to multiply through by a constant. And this time, instead of plugging in 1, we are going to plug in 2. So 2 is being substituted in. We're finding f of 2. So 2 cubed is 8. And then this is going to be 4 times 4, because 2 squared is 4, minus 31 times 2 minus 174. Use my handy-dandy calculator here. So we've got 8 plus 16, and this is going to be minus 62 minus 174. That is negative 212. So a times negative 212 equals negative 636. If we divide by negative 212, then we find that a is 3. So if a is 3, then that means we have to take that value, substitute it right back in there, and this, or actually here, there is a. There's where we got to multiply by a, because 3 times that would equal negative 636. Therefore, since a has a value other than 1, we've got to multiply the polynomial by that coefficient, which is going to change our answer. So it's going to be 3 times f cubed, or x cubed, 3x cubed. 3 times 4 is 12x squared. 3 times 31 is 93, so minus 93x. And then 174 times 3 is 522, so minus 522. That is your f of x. So this is your polynomial that has these zeros and passes through the point to negative 636. Let's give it a quick check on the graph and we'll verify that it's correct. So 3x to the third plus 12x squared minus 93x minus 522. We graph it, and then we're going to check that table of values one more time to be certain that 2, negative 636 is actually in the table of values. So zooming in on the calculator here, may not show yet. Table of values. We're looking for positive 2 and 636. So we're good. That's the check.